Merci beaucoup pour l'invitation. Je suis belge, flamand, donc je devrais être en fait capable de vous parler en français, mais malheureusement, je n'ai pas vraiment utilisé le français très souvent les derniers 20 ans, et j'espère que je vais nous tous, vous et moi-même, faire une faveur par parler en anglais. Mais n'hésitez pas de me poser des questions en français, je suis bien capable de les comprendre. I will present to you today the work of the Kitab project, which is an acronym that stands for Knowledge, Information Technology, and the Arabic Book. For those not familiar with Arabic, Kitab also means a piece of writing, especially a book. The project is led by Sarah Savant and is based at the Center for the Study of Muslim Civilizations at Aga Khan University in London. During this presentation, I will introduce you to our project by explaining its main goals and research questions, the tools we are developing to answer our research questions, and a couple of examples of how we use these tools. And finally, I will also talk a little bit about challenges and the future of the project. Let me first introduce you to the team. So to the left, you see our PI, Sarah Savant. The other people are the main Kitab research team, most of whom are located in London, except for Maxime Romanov, who is at Vienna University. We are all mostly historians. We also have a technical team supporting us, some of whom are in London. Masoum is in Leipzig, and David and Ryan are in Boston in the US. David and Ryan are part also of a sub-project of Kitab, which is called the Digital CR project, which works on a lost work on the life of Muhammad. And finally, we have two people who are mostly working on annotating text in our digital corpus. And as in any of these big projects, we have some people who are extremely important to the project and who take care of the administrative burden. So the project is funded by the European Research Council, the Aga Khan University, and the British Academy. The Digital CR project I mentioned before is funded by Qatar National Library, and we also are partners in a project on OCR, optical character recognition for Arabic, with the University of Maryland, which is funded by the Andrew Mellon Foundation. And we have people who collaborate with us at a number of universities, mostly in the US and in Europe. So let's talk first about our research questions. The main goal of the Kitab project is to stimulate computer-aided research on the history of the pre-modern Arabic written tradition. One of the main desiderata for such research is a reliable, machine-actionable corpus of texts, and that's what we are developing in this project also. I will talk about this immediately. And the primary focus in our research for now is the concept of text reuse. Texts in our corpus have a very high level of intertextuality. They quote each other all the time. And algorithms that can detect this text reuse can help us to take a bird's eye view of this phenomenon. And this allows us to answer questions such as how books were written, how knowledge was transmitted, how this changed over time, how new ways of citation created changes in books and the size of books also, how widely text travels, etc. So such a computer-based approach needs a solid basis in the form of a machine actionable corpus of text. It has to be said that huge efforts have been made in the last 2 decades in the Islamic world to digitize pre-modern Arabic texts. This usually happens by double keying. I wish I had nice pictures like Elena for this, but basically it's 2 persons typing the same page and a computer program then comparing the 2 pages to spot mistakes. Large digitized text archives like Maktaba Shamila have become an important tool for researchers, but the available collections have a number of downsides. One of them is that they were usually created by religious foundations, and the selection of texts they contain are often biased by their specific outlook. For example, in a Maktaba Shamila, especially in the earlier versions, you would find very few Shi'i texts, and in general, very few texts without a religious focus or use. Moreover, these texts are often in a format that's not easy to use for computational analysis. The OpenITI corpus tries to overcome this and aims at creating a more comprehensive and more representative corpus of pre-modern Arabic texts, not just in Arabic, but also in other languages from the Islamic world, Syriac, Persian, but for now, almost all texts in the corpus are in Arabic. And the main focus of the corpus is from about 800 to 1500 of the Common Era, but we have a good number of later texts as well. The open in OpenITI is double. It means that it's open for use, but also that it's open in the sense that the texts are in a simple format, which makes it easy to use for computational analysis. It's just simple text in which very limited tags are introduced. These tags are in a markup language called Markdown. It's a special flavor of the markup language Markdown, OpenITI Markdown, which was developed by Maxim Romanov. The main aim is to tag pre-modern Arabic text in a quick and easy way without dealing with the clash between right to left and left to right languages, as you have, for example, with XML. For example, it uses a simple hashtag to indicate the beginning of a new paragraph, 3 hashtags for the beginning of a new section in combination with a number of pipes, these vertical lines you see there, for first level sections, second level sections in order, and so on. So because our texts are simple text files, they can be read in any text editor, but in the project we use a specific editor called EditPad Pro because it handles Arabic scripts and very large text well. In addition, it allows the user to develop their own highlighting schemas that highlight specific patterns in the text. You see this happening here. So it's useful as a quality control for annotating text because tags are only highlighted when they are correctly written. And when structural tags are added to the text, as you see here, you see the color change. And once you have this, you can fold all these headings. So you get a kind of table of contents, which you can again use to check if you tagged everything correctly. This markup language also can be used for tagging other elements in a text and structural elements. For example, you can tag named entities with them, places, persons, years, pre-mark, Quran citations with it, and so on. But for now, in the most text in our corpus, we will find only structural elements marked, because we focus on this because it aids the computational analysis in a later stage. So it's mostly used, mostly developed as a shortcut for scholars who want to speed up tagging their texts, and the tags can then be converted into TI XML format or in any other formats you like. They can be removed from the text if one wishes to do so easily, and you can use it to extract data into a database. Special version of OpenITI Markdown is also in development for use with manuscript transcriptions. If you are interested in this, you can follow these two links. I will share this presentation later, so you can just follow the links in the presentation. So to get back to the corpus, some statistics about the text in our corpus. The corpus currently contains more than 7,000 texts. 4,300 of these are unique texts. With unique, we mean that sometimes the corpus contains more than one version of the same text. If that's the case, we make the best version the primary version, and all other versions become secondary. This is useful if we want to do a statistical analysis of the text. When I say the primary text is the best text, this can mean many different things. It could be that it's based on the best edition, contains the fullest version of a text, or the cleanest digitized text. We don't have a specific rule for this. We have to decide on a case-to-case basis. The text in the corpus range from very short to extremely long text, from 100 words to about 10 million words, and in total it contains 1.5 billion words. Just to give you an idea, in comparison, the Greek and Latin collection of the Perseus Digital Library contains less than 70 million words, and on the other end of the scale, Wikipedia in English alone contains 3.6 billion words. So it's big data, but not really big data. The following graph shows you a distribution of the corpus over time. So on the bottom, you see the centuries in the Hijri era. So you can see that for the first 2 centuries, we don't have much literature because not much is extant, in fact. And most of our texts are from the 3rd to the 8th centuries. The blue bars represent all different texts in the corpus, and the dark blue are distinct books. So the primary text, let's say, red is for the author. So you can see that we have about 2 versions on average for each book, and two books per author each on average. You can also see with the jagged line in dark blue that the number of words per book varies a lot. So especially in the 8th century, you can see that there's a large growth in verbosity of these books. Okay, this slide shows the workflow of the project. The first phase on the left consists of data and metadata collection. Second phase of adding structure to the structural markup of the text. Data is stored on GitHub in ever-changing conditions, but every now and then, we try once or twice a year, we release a stable version of the corpus on Zenodo, which can be then quoted in publications, etc. These releases are connected with iterations of our text reuse detection algorithm PASM, which I will also discuss in the next few minutes. So we're continuously building up our corpus. The first step is in identifying existing digitized collections of texts. These include large collections like Al-Maktaba Shamila and the Shia Online Library, but also smaller collections of individual researchers or teams that have digitized texts during their projects. If you yourself have digitized text or know people who have digitized text, we would be very happy to add them to our corpus. And I think you'll see that will be useful for you, for them as well. As I mentioned before, one of the main issues with our corpus is that our source collections each have their own bias. We actively try to identify gaps in our corpus by comparing the corpus to bibliographical texts, both modern and pre-modern, and by actively searching for texts representing minority communities like Ibadis, Zaidis, etc. We are also working with researchers at the University of Maryland to create an OCR pipeline to get more books into the corpus. As you probably know, OCR, optical character recognition, turning scanned images into computer-readable texts, is still highly problematic for Arabic, with far lower accuracy than for Latin scripts and Chinese, for example. A number of academic projects and companies are currently trying to crack this problem, and it seems that we're making good progress, and we hope that with machine learning techniques, there's good hope that we can, within the next year or two, have a performative OCR pipeline in place to bring new books into the corpus. We are currently training OCR software to recognize the main typefaces in which printed editions of Arabic texts were produced. So collecting text is only the first part of our corpus building process. The next step is identifying these texts. So we get sometimes thousands and thousands of books from a digital collection, then we have to identify these with the books that are already in the corpus. The way we do this is we give a URI, a unique resource identifier, to each of these books. This consists of sub-URIs and ID for the author, consisting of his approximate year of death, an ID of the book, with the short title, version ID that refers to the collection we originally got it from, and a language code, Arab for Arabic, for example. And finally, a digit that allows us to differentiate between different editions, paper editions of the same text. In the future, each paragraph and section in the text will also be given an ID so that you can quote specific section independent of page numbers of the specific edition. The different parts of a URI define also the folder structure in our corpus. Different versions of a book are grouped in a book folder that has the book ID as its folder name, as you can see here. All books by an author are grouped in the folder that has the author ID as its folder name. Metadata files are grouped with the books they describe and with the authors they describe in files that have exactly the same file name with a different extension, YAML, which stands for yet another markup language. And it's like everything in OpenITI, a format that's easily readable for both humans and for computers. The space where we save our text and do most of the corpus work is on GitHub. Oh, sorry, I went a bit too fast. So on GitHub, there's a limitation to the size of folders, and so we split the corpus into smaller subfolders in buckets of 25 years. So you can see, for example, all the authors who died between 151 and 175 are collected in this folder. So why do we use GitHub? First and foremost, it's a distributed file versioning system. It keeps track of changes made to every file you store in it, and that makes it possible to reverse changes if something goes wrong, which is very useful. It also keeps track of development of the project, and can also be used as a way to communicate with users, and users can help in the development of the project by using this system. It's mostly used by software developers, but it's very useful for anyone working in a team, I would say. The structure of GitHub also invites cooperation from outside users. Almost all of our work is openly visible to other researchers and developers, and they can find and report mistakes, propose features, request permission to make changes themselves, etc. And finally, also important, GitHub offers a large amount of free storage space for academic projects. There are also downsides to using GitHub. Was developed for software programmers, not as a text repository for static files, so we're using it in a way it was not meant for. Has limits in text in file size, quite high limit, it's 100 megabytes. We currently have only one file that is too big for it, and which we had to cut up to fit in there. There's also a political issue with GitHub. It was acquired by Microsoft in 2018. The issue is not that Bill Gates is supposedly trying to microchip all of us, but that it's an American mega corporation. And so it's forced to follow US government guidelines related to anti-terrorism and embargoes. We had, for example, an issue last year where we were frozen out of our GitHub accounts because we have two people who work for us who are Iranians, and so somehow we got onto a blacklist. Problem was solved in the end, but it does make you think about using this type of tool. Our GitHub page, if you want to take a look at it, contains many different repositories. One of the downsides of GitHub is also that it's not really organized, so you have to know what's there, in fact, to find it. The text repositories you will recognize by now because they have these this format of 25 years in history era. We have a number of other text repositories, for example, for the release data that will be periodically released to Zotero, sorry. We have a public release coming up at the end of this week, in fact. We also have repositories you can use to get yourself more knowledgeable about how we work. We have a Python library that you can use to work with OpenITI, and we have various other repositories that are maybe of less interest now. One of the main problems there is that, okay, we have all these texts. How do I find a book? This is one of the questions we often get. We have a search app for this that's available online. You can find a link here. And with the releases, you also get some downloadable app you can use to search books. This is more or less how it looks. You can filter books by search query, its annotation status, or whether it's a primary or secondary book. These are all links, so they bring you to the text. If you use the online version, it will bring you to the GitHub page. If you download it with the release, it will get you to the text on your own machine. This will get you to the book folder and to the author folder. It also tells you the number of words, so you can also sort the books by this category. And we have classification tags. We don't like to use the term genre. They come from the libraries themselves, from Brockelmann's Geschichte der arabischen Literatur, and we have some of our own tags as well. You can also use this search app to raise issues about the text. So you can tell us that you think, for example, that there is a mistake in the author name here, or that you think that there's a much better version of this text in the corpus, and that should be the primary text. Let's move on now to text reuse, which is maybe the most central idea of our project. We use an algorithm to lay bare the highly intertextual nature of the early Islamic corpus. The algorithm is called PASM and was developed by David Smith for studying how news spread in 19th century American newspapers, and is being adapted to Arabic text by his PhD student Ryan Muther. I will give you a quick look under the hood of the algorithm so that you can see how it works. I will not go deeply into technicalities, but you can ask if you're interested in that. There are a couple of preparation steps we have to take before we can feed our text to the PASM algorithm. First, we have to normalize characters that can be used interchangeably, and we cut up each text into 300-word chunks. Because PASM has problems dealing with comparing huge documents with very small documents. These are saved as JSON documents, and our 7,000 texts in the corpus are thus cut up into a heap of 2.3 million text snippets. Then we feed these snippets to the PASM algorithm, which goes through 3 steps. First, we reduce the number of pairs of snippets we have 2.3 million documents. That would mean 2.8 trillion pairs, which is way too much, way too high a burden for our computer systems. So what we do is we convert each document into n-gram collections. N-grams are sequences of a number of characters or words. We use 5 as a default. So to show you what happens is, you can see here an example of an 8 token string, and it's cut up into 4 bigrams by always moving one word forward. These are then indexed in the entire collection, so we check in which text, in which documents n-gram A is present and n-gram B is present in a number of other documents, and so on. And then finally, we retain only the pairs of documents that have more than 10 n-grams in common. It's important to note that we don't count extremely common n-grams to get to this number of 10. So, for example, very common phrases like Sallallahu Alaihi Wasallam will probably not be meaningful reuse of text, so we leave them out of the equation for now. They will be considered later again. So by doing this, the 2.8 trillion possible document pairs are reduced to only 39, almost 32 million pairs, which is much more easily handleable by our computer systems. In a second step, an algorithm is used that's taken from bioinformatics to align passages within these document pairs in more detail. And also with a higher level for a higher sensitivity to possible differences. And then in the last step, all these passages that were found are clustered together across these chunks, because sometimes a passage is at the beginning of a chunk, and we then check if it is to be connected with something at the end of the previous chunk. For each matching passage, we get an output with a lot of metadata for this specific match, and all these matches are then gathered together in a document. All matches for one document pair are connected then in one document. So this is maybe the most interesting visualization for what we get for this. From the PASM output, you get the two texts in the two different documents, and in the texts that are missing in one document is indicated by these dashes. So here you can see that the kala is missing here. Here, a different formula to praise Allah is used in both different texts. So how widespread is this text reuse? The highest amount of text reuse between two pairs is 28,000 records almost. But on the other hand, very few texts have so much in common, and most texts have less than 10 records in common, in fact. More interestingly, For about 25% of the books in the corpus, more than 50% of the text matches another book, and about 20% of the books in the corpus we have more than 1,000 records in common with another book. So this shows you that there's a very large amount of meaningful text reuse between books in our corpus. What can we do with this now? We can look at the relationships between two texts. We can look at which texts in the corpus are especially closely related and learn from this. We can explore the makeup of complex text by looking from which component text it's built up. We can chart how IDs and texts are recepted, how they are requoted across centuries and across regions also. You can also look into much more detail on a close reading level after selecting text by distant reading. And I'll just show you some examples of how we can visualize this text reuse. We have a visualization app for this. And this is an example from my own backyard to 10th century geographical works by Identifier and Hakal, of whom the latter is clearly based on the former. What happens here is that the text is cut up into 300 word chunks. Each of these are represented by a vertical wide bar, and on this wide bar, the parts of these 300 words that are found in the other text are marked in red. So you can see also that that the red bars are then connected to the other text with these yellow lines. So you can see that in this one that the structure of the text or the second text follows the first one very closely. All these lines are more or less parallel. You can also see that here there was a big white space. This represents a chapter that was fully rewritten by Ibn Hakal based on his own experience and not based on Istahri's text. We can also notice that there are some lines that seem not to follow the same pattern. In the app, you can then click on these lines and see the alignment of these texts again, as we saw before. So the black text is the text that is in common between both texts, and red here is text that's only in version 1. Green is only in version 2. Sometimes this doesn't tell you enough yet, so you can also read the text in more context. Next to each other. We're also developing a reader for these texts that will indicate that will include this text reuse information. In this case, for example, you can see that the section in which this reuse is detected is in fact an editorial section. And you can see that there's editorial sections at both ends of the book, and they account for these strange lines that quote from different parts of the book. Sometimes this visualization can be very useful also to see visualize structural difference between texts. So for example, this is one of the earliest legal texts, Malik al-Muwatta. We have many different transmissions of this text. These are two. You can see that by the red lines that they have almost the same text, but the yellow lines show you that so there's a clear different order of how the text is presented. This is an example of what a commentary on a text usually looks like. With the text reuse, you can see Malik al-Muwatta again on the top, and a later commentary. So you usually in these commentaries you get red bars combined with much white space in between, which then represent the comments on the text. So there are a couple of challenges also. One is that text reuse in the Quran is very underrepresented in the corpus because of what I explained of the first step of the PASM algorithm that throws out very commonly used 5 grams. So yeah, since the Quran is quoted so often, this will not count to the threshold for comparison by PASM. We will use a Quran verse identifier on the entire corpus to fix this. The second problem is that text reuse detection is not the same as source detection. So very often you will find for the same passage many different sources that share the same text. That doesn't show you which text the author used. More analysis necessary to detect that, and we are currently working on that. And also we have been working mostly until now on book-to-book comparison, and we'll focus more on many-to-many relationships between books. I will leave you with a couple of links where you can find more information, and I will end with an invitation to all of you, if you are interested, to please contact us if you want to play with our research data, if you want to add your own data to it to see if you can find text reuse between your data and the corpus. You're more than welcome. Thank you.